Section 12.5, the normal distribution. There are two kinds of random variables. A discrete random variable can take on only certain fixed values. Example, you toss 5 coins. The number of heads that can appear is either 0, 1, 2, 3, 4, or 5. So x is a discrete random variable. A continuous random variable can take on all real number values over a range. Example, the diameter of a flower blossom can be any value between 5 and 25 centimeters. So y is a continuous random variable. The probability distribution of a discrete random variable x describes how the data is spread out over the values of the random variable. Example 1, toss 5 coins. X is the number of heads that turn up. Construct the probability distribution of x by filling in the frequency and probability that the discrete random variable assumes value x. So our number of heads is x. There is one way to have 0 heads. The probability of that happening is 1 out of 32. There are 5 ways to have 1 head, 10 ways to have 2 heads, 10 ways to have 3 heads, 5 ways to have 4 heads, and 1 way to have 5 heads. The probabilities are 5 out of 32, 10 out of 32, 10 out of 32, 5 out of 32, and 1 out of 32. Example 1b says to construct the histogram for the probability distribution of tossing 5 coins, where x is the number of heads that turn up. So we either have 0 heads, 1 head, 2 heads, 3 heads, 4 heads, or 5 heads. And up the side is the probability that it happened. 1 out of 32, 5 out of 32, 10 out of 32, 10 out of 32, 5 out of 32, and 1 out of 32. Up the side, 1/10, 2/10, and 3/10. Each bar in the histogram is 1 unit wide. The area of each bar is equal to its height times 1. The sum of the areas is the total probability, which equals 1. The probability distribution of a continuous random variable x is the graph of a continuous curve, y equals p of x, that is positioned around the mean. Y equals p of x is a symmetric bell-shaped curve called the normal curve. The area under the graph is equivalent to the probability that the random variable will have a value in the corresponding interval. Normal distributions. 0 would be our mean, 1 standard deviation away, 2 standard deviations away, 1 standard deviation to the left, 2 standard deviations to the left. A normal distribution is a bell-shaped probability distribution that is symmetric with respect to the mean. The concavity resets at the mean plus 1 standard deviation and the mean minus 1 standard deviation. These are called points of inflection. It is asymptotic to the x-axis. The curve will never touch the x-axis. It will get closer and closer and closer, but it will never touch. The word is asymptotic. The x-axis is an asymptote. A standard normal distribution is symmetric with respect to 0 and has points of inflection at 1 and -1. The empirical rule says the percentage of data values within given distances of the mean are approximately as follows. 68% of the data happens within 1 standard deviation of the mean. 95% of the data happens within 2 standard deviations of the mean. And 99.7% of the data lands within 3 standard deviations of the mean. Example 2. 300 chemistry students took a midterm exam. Assuming their scores are normally distributed, use the empirical rule to estimate the number of students who scored within 1 standard deviation of the mean. Remember, the empirical rule says 68% of those students score within 1 standard deviation of the mean. So we're going to multiply 300 times 0.68 and estimate that 204 students score within 1 standard deviation of the mean. Within 2 standard deviations of the mean, using the empirical rule, 2 standard deviations of the mean includes 95% of the data, so 300 times 0.95 tells us that 285 students scored within 2 standard deviations of the mean. The z-score of a data value x is the distance between an observation point and the mean, or the number of standard deviations between a given value and the mean. Our formula to find the z-score: z equals x minus x bar divided by s. Remember, x bar is the mean, x is the data point, and s is the standard deviation. Example 3. The mean height of male students at Western University is 70 inches with a standard deviation of 2 inches. Compute the z-scores for the heights, x, in the following table. Data point minus the mean divided by s. So for 66, we're doing 66 minus 70 divided by 2, which is -2. 68 minus 70 divided by 2, which is -1. 70 minus 70 divided by 2 is 0. 72 minus 70 divided by 2 is 1. And 74 minus 70 divided by 2 equals 2. Excuse me. Example 4. Rose and Wanda are in different sections of history but took the same midterm. Rose scored 86 and Wanda scored 78. But Rose's class mean score was 73 with a standard deviation of 8, while Wanda's class mean score was 69 with a standard deviation of 5. Which student performed better relative to her class? The first thing we will calculate is the z-score for each student. 76 minus 73 divided by 8 is 1.625. 78 minus 69 divided by 5 is 1.8. The answer: Wanda's z-score of 1.8 is greater than Rose's z-score of 1.625. Because z-score is the distance between the observation point and the mean, Wanda did better than Rose relative to her class. Example 5. Find the area under the standard normal curve. Use areas under the standard normal curve table. You'll find the standard normal curve table on page 715 in the textbook, or there is a table posted on D2L with this section's video and notes. Find the area under the curve between z equals negative 1.45 and z equals 2.71. The most important thing to do is draw the curve. 0 is right here. So this is 2.71, and this is negative 1.45. We're going to find this area and this area. Z equal to 2.71 gives the A value of 0.497. Z equals negative 1.45. Use 1.45 on the table because the curve is symmetric around the mean. And we find that A equals 0.426. The total area, we're going to add them together. So this one is 0.497. And this one is 0.426. Total area is 0.923. Again, we're using the area, finding the area under the curve, and we're using the table. So we're going to find the area between 0.62 and 1.59. Draw the picture. 0, and we'll go to 0.62 and 1.59. We're trying to find this area here. Z equals 1.59 gives an A area from the table of 0.444. Z equals 0.62. From the table, we know A equals 0.232. We're finding the area in between them. Our total area, we're going to need to subtract these values. 0.444 minus 0.232, which is 0.212. Example 6. 300 chemistry students took a midterm exam. Assuming their scores are normally distributed, use the standard normal Z table to find the number of students who scored between the mean and one standard deviation above the mean. One standard deviation means Z equals 1. Thinking about our curve, this is going to be our mean. And our one standard deviation, our Z is going to be 1. Given Z equals 1, A equals 0.341. That's 34.1%. 2.45 standard deviations below the mean. Z equals 2.45. Given Z equals 2.45, A equals 0.493. It's 49.3%. To find the number of students, we then multiply by 300. So 0.493 times 300. and 0.341.